Okay, let's take a look at this. So solve by factoring. So that kind of gives you a little hint on how you want to proceed. So first what we're going to do is set this equal to 0. So what I'm going to do is subtract by sine of x on both sides. And so you got to be careful here because you're not going to cancel out those signs of x right there. You can't do that because they wouldn't be considered like terms. So now we're going to be left with tangent squared of x times sine of x. And then now we have that minus sine of x. And now we're set equal to 0. So that's the first thing you want to do. And then now here's the factoring part. What we're going to do here is we're going to factor out the sine of x. So we factor that out. And that would leave us with tangent of x squared minus 1 and then equals 0. So if you kind of go in reverse, see if I were to distribute the sign, I'd go back to my previous step. Now, I don't want to do that. I want to continue to factor. And so then next, what I'm dealing with here is the difference of two squares right here. Because I could basically square that one and it's still a 1. And so I have tangent squared minus 1 squared. So that's the difference of two squares. And so I can factor that into tangent of x plus 1 and tangent of x minus 1. Put that in parentheses. Okay. And so equals 0. So if you look at this, if you were to foil this, you'd go right back to what I have in red right here. And so once again, we don't want to do that. We want to continue, but I just want to, in case you're kind of unsure how I did that, you could always foil it back together and you could kind of see, oh, okay, that's equivalent to what I have above. Okay, now the idea is to get these all into linear terms, which now they are because I don't have any exponents other than the understood 1 for all these. So what we do now is we're going to set these all equal to 0 and solve, and that's how I find my solutions because they're all getting multiplied together. And so if any of them equals 0, if this equals 0 or this, if any of them equals 0, the whole thing goes to 0. So first one we're going to have is sine of what angle gives me 0. And so we'll have to figure that out in a second. Then we have tangent of x plus 1 equals 0. And then we have tangent of x minus 1 equals 0. So those are my three equations that I end up with where I'm trying to figure out what makes each one equal 0 because, like I said, if any of them equal 0, 0 times anything would just eliminate everything that's there. Okay, so we'll start with sine. So let's see, what angles of sine do I get 0? Well, that would be for 0 degrees and then also for 180 degrees. And actually, I think you're doing this in radians. So let's see, that would be 0 and pi. So there's two of my answers. That's not all of them, though. And then let's see here, I got to subtract by 1 on both sides. And so I end up with tangent of x equals -1. So let's see, where's tangent -1? Well, if you were to kind of visualize your unit circle, let's see, you're going to have it right there and also over here. And so let's see, that first one, that would be 3/4 of a pi. So that's one of my solutions, okay? And then let's see the other one. Let's see if I had to go around again. So let's see 8. Let's see 9. That'd be what 11 pi over 4. Okay. Oops. Hold on 1 second. Actually, I'm sorry. I went too far. I accidentally did a whole 360. I was trying to add a pi onto this, and I accidentally added too much. So actually, I just need to add 4 to that. And let's see, that would give me 7 pi over 4. So my apologies. Sorry. I hope I didn't confuse you there. So this right here is 3 pi over 4, which tangent is -1. And then over here it's 7 pi over 4. So sorry about that little mix up there. Okay. And then the other one, let's see, we're going to add 1, add 1. So now we're looking for where is tangent, what angle will give me +1. And so that's going to be right here at pi over 4. And then now I do a half a rotation. So basically, I need to add pi to this. So that would be 5 pi over 4 right there. So that would be where that's at. And so, yeah, let me write those down. So pi over 4 and 5 pi over 4. So we actually have 6 total solutions to that equation. So we have the 2 here, the 2 here, and the 2 right there. So all 6 of those. All right, let's look at the next one. I believe it's kind of a similar process. Um, okay, yeah, so it's a trinomial. Okay, so basically you need to kind of look at this as though it were 6x squared plus 5x plus 1. And sometimes it's helpful to do it this way. Basically, you're using a process called substitution. So right now, instead of having sine um, squared, I have x squared. Instead of sine, I've got x. So basically, for a minute, I'm just going to go ahead and let x equal sine of x. And so if that's the case, then sine squared would be x squared. Anyways, it makes the process a little bit easier. Okay, so now I got to go ahead and factor this trinomial. And this one actually is pretty simple. This would factor into 3x and 2x. And then to multiply to get 1, it's just going to be plus 1 and plus 1. And so if you look at this, if you were to FOIL this, these two things right here, they're equivalent. They're just in different formats. One's factored. So see, 3x times 2x is 6x squared. Then the outer and inner gives me that 5x. And then 1 times 1 is 1. So just doing some factoring. Okay, now that I have that, I'm going to go ahead and replace x for what I substituted here. And so let's go ahead and rewrite this. So let's see, I'm going to have 3 times sine of x plus 1, and then times 2 times sine of x plus 1. And actually, now that I think about it, I think in your email you had mentioned this, that you'd gotten to this point. So let me just go ahead and write this down. So you get to sine of x equals negative 1/3, and we get sine of x equals negative 1/2. Okay, all right. Okay, so now what we want to do is figure out this. And so we do have exact solutions for sine of x when it equals negative 1/2, but we don't have that for negative 1/3. So we'll deal with that in a second. But either way, it's going to be helpful to kind of have a visual here. So here's our unit circle. So sine is negative 1/2 in two places, right here and right there. Okay, so let's see. This first one's going to be at 7 pi over 6. And let's see, this other one's going to be at 11 pi over 6. Okay, for the second one, part of this, I did go ahead and grab my calculator because we are going to need this for this. But you still need kind of maybe a little visual of this to still kind of help us out here. So that 1/2 is referring to the negative 1/2 right here. It's referring to the y distance that occurs right here to get to that angle right there. That's the negative 1/2, assuming that this is positive 1 right here, the unit circle, right? The radius is 1. This distance right here, and it's not, completely um, to the same scale, but close enough. And so what we're looking for now is we're looking for that distance to be negative 1/3 instead. So it's going to be a little less than that. So it's going to be about right there and about right there. And so let's go ahead and put this in the calculator and see what happens. So first of all, I need to make sure I'm on radians. So let's go to mode. I'm on degrees, so I got to change that to radians. And then, see, yeah, okay, good. And then, so what I have to do is I take the inverse. So sine inverse of negative 1/3. And what's going to happen is I get an answer that's not within the domain of the original question. So the domain is from 0 to 2 pi, which is about, 6.28 or whatever, right? And so this is giving me the angle as though I were going in clockwise instead of counterclockwise. So what I'm going to do here is I'm going to go ahead and add 2 pi to this, and that will swing me around into the positive position of this. It'll be coterminal. So let's see, I'm going to add 2 pi. Okay. And so that's going to be one of my answers right there, 5.94 or so. So that's what this is going to be, right? Oops. Well, that'll work. Um, that'll be about 5.94. And so that's this angle going around like this right there. Um, remember, 2 pi is about what, like 6.28 or so. So see, I'm a little off doing a full rotation right there. And so that's the 5.94. Now, to figure out this other angle, what I'm going to do here is I need to figure out from here to here, right? Well, I know to this point right here would be pi, right? To this point would be pi to just do a half rotation, but I need that extra little sliver. Well, I know what that little sliver is because I got it when I first put it in the calculator. Because see, that little sliver is basically negative 3.4 right there, right here, this angle right here. That right there, so negative 0.34. So see those two angles right here, they're actually coterminal. They terminate at the same spot, one going clockwise and one going counterclockwise, the traditional way we like to go around right here. So anyways, that angle right there is negative 0.34. Now, if I here I'm measuring it in the positive counterclockwise position. So this would be positive 0.34 right here. So what I'm going to have to do to figure out this angle right here, I'm going to have to take pi and add 0.34 to it. And then that should give me my other angle. So here we go. Let's see. Pi plus 0.34. And so we're going to get 3.48. So that's going to be that angle right there. So 3.48. Okay, so don't forget the original ones we got with the nice ones for the sine of x equals negative 1/2. And then for the negative 1/3, it got a little bit messy, and it can be a little confusing. That's why I said, drawing a picture might help. I know my picture might be a little messy, but hopefully that makes sense to you. And if you have any further, questions, don't, hesitate to send me another email.